Good morning. So we're ready to start chapter 4. This is all about the atom. It does have some math, but not quite as math intensive as last chapter, which is, I think, good news. So, early models of the atom. There were actually a Greek philosopher, Democritus, proposed the idea of the atom. And then John Dalton is one that is currently credited with the first model of the atom. So the atom is the smallest particle of an element that retains its identity in a chemical reaction. Early philosophers and scientists couldn't see these little tiny atoms, but they were still able to propose them and determine various parts of the structure of the atom. So Democritus was living a long time ago, and no, you don't need to know those dates, but he was the first to suggest the existence of the atom. Democritus reasoned that atoms were indivisible and indestructible, and interestingly enough, Socrates was a contemporary of Democritus, and he disagreed. And since Socrates was such a well-known philosopher, Democritus' ideas were abandoned until the time of John Dalton. So, he didn't use any of the scientific method. He didn't have any evidence, so it never became a theory. Which are all things that Dalton did do. So Dalton was really the first one to use the scientific method to develop an idea of the atom. No, you don't need to know his dates, but it's interesting that it was a very long time ago. By using experimental methods, Dalton transformed Democritus' ideas from a philosophy into a scientific theory, which is really important for us as chemists. He studied the ratios of elements and how they combined, and as a result of this, he has Dalton's atomic theory, and you do need to know the postulates of Dalton's atomic theory. And those postulates or those ideas are: 1, all atoms are composed of tiny, indivisible particles called atoms. 2, the atoms of a same element are identical. The atoms of another element are very different from those of the first element. This has actually been modified a little bit. But that's what happens with good theories. They do get modified and revised. 3, atoms of different elements can mix physically together or chemically combine into small whole number ratios to form compounds. Chemical reactions occur when atoms are separated from each other, joined, or rearranged in different combinations. Atoms of one element are never changed into atoms of another element as a result of the chemical reaction. And this directly opposes what the alchemists were trying to do, which was convert atoms of lead into atoms of gold. They never did get it. How was John Dalton able to study atoms even though he couldn't observe them directly? What evidence did he use to formulate his atomic theory? He studied the ratios in which elements combine in chemical reactions. He observed when the atoms mix, they maintain their own identity unless they are combined in a chemical reaction. How was Democritus' idea of the atom different from Dalton's? Democritus' idea did not explain the chemical behavior and was not a scientific theory because it lacked experimental support. Using experimental support, Dalton transformed Democritus' ideas about atoms into a scientific theory that explained chemical behavior. So, what instruments are used to observe individual atoms? Well, this is liquid mercury, and I think I showed you guys gallium as it melts and looks very much like this. But every drop, no matter how small, still has the same properties. If you can make a drop the size of one atom, it would still have the same chemical properties of mercury. Likewise, if you were to grind up a copper coin into fine dust, each speck in the small pile of shiny red dust would still have the properties of copper. In fact, we made copper when we did our experiment about observing a chemical reaction. That reddish brown paste, that was actually copper. If you could continue to make the copper dust smaller and smaller, you would eventually come upon a piece of copper that could no longer be divided, and that final particle would be the atom. Atoms of pure copper, a pure copper coin the size of a penny contains about 2.4 times 10 to the 22nd atoms of copper. And you notice they said a pure copper coin. Today's pennies are not pure copper. They actually have a zinc core, and then the outside is copper on the outside. By comparison, today's population is only about 7 times 10 to the 9th people. That number is out of date. If you could line up 100 million copper atoms side by side, they would produce a line only 1 centimeter long. Despite their small size, individual atoms are observed with instruments such as a scanning electron microscope. Scanning electron microscopes, a beam of electrons is focused on the sample. The electron microscopes are capable of much higher magnification than light because the wavelength of the X-rays is so small. With the help of electron microscopes, individual atoms can be moved around and arranged in patterns. The ability to move individual atoms holds future promise for the creation of atomic-sized electronic devices, such as circuit boards and computer chips. They've actually made little, screws and very simple machines so far. An example of a device made from individual atoms is the nanocar shown here. The atomic scale or nanoscale technology could become essential to future applications in medicine, communications, solar energy, and space exploration. And so you can see, here's the arrow, and on the left and the right we see 3, just a little bit of the 4th tire, and then the central part would be the body of the car. Electrons in the structure of the atom. Atoms are the smallest particles of an element that still have its chemical properties of that element. However, I think we're almost to the end of this section. Democritus reasoned that atoms were indivisible and indestructible by using experimental methods. Dalton transformed Democritus' ideas about atoms into a scientific theory. Scientists can observe individual atoms by using instruments such as scanning electron microscopes. We have a couple of vocabulary words. Dalton's atomic theory, the atom. And that's the end of it for this section. I will see you soon. Bye.